Look up at the night sky, the twinkling stars, distant galaxies, brilliant nebulae. All the beauty we see, all the matter we have ever known, from the planet we stand on, your body, to the farthest stars, only make up a very small part of the universe. So, what if I told you that everything we see is only 5% of reality? That the remaining 85% of the universe is something completely invisible, non-luminous, non-reflective, and does not interact with light? A giant ghost present everywhere, controlling everything, yet evading all our attempts to observe it. In today's video, we will begin the hunt for the greatest mystery of all time: dark matter. What is it? How do we know it exists, even though we cannot see it? And how is it silently shaping the fate of the universe? Let's lift the veil of darkness together. The first and most important question: if we cannot see it, how do we know it exists? The answer lies in one of the most fundamental laws: gravity. And the great credit goes to pioneering astronomer Vera Rubin. Imagine a merry-go-round. People sitting near the center spin faster than those sitting at the edge. The universe works in a similar way. In a galaxy, stars near the center, where there is more visible matter, should be spinning faster than stars at the far edge. But when Vera Rubin observed galaxies, she discovered something astonishing. The stars at the outer edges were moving almost as fast as the stars at the center. This completely contradicts the laws of physics. Their speed was so high that the gravitational force from the visible matter could not possibly hold them in place. They should have been flung out of the galaxy long ago. The only explanation? There must be something invisible, a massive amount of matter creating extra gravitational force to hold everything together. That is dark matter. Evidence for dark matter does not stop at a single galaxy. When we look further out to galaxy clusters, the story becomes even clearer. The galaxies in a cluster do not stand still. They continuously move, orbiting around a common center of mass, like a grand cosmic dance. And once again, astronomers measure their speeds. They are moving too fast, so fast that the gravitational force of all the visible galaxies combined is not enough to keep them within the cluster. Without dark matter, these galaxy clusters would have dispersed billions of years ago. Dark matter is the invisible cosmic glue that holds the largest structures in the universe together. It is the invisible conductor, directing the dance of thousands of galaxies. It is not a chaotic cloud. Through computer simulations and indirect observations, scientists have drawn an astonishing map. Dark matter forms a gigantic structure stretching across the universe, called the cosmic web. Imagine a giant framework of a house. Dark matter is the beams and invisible pillars that make up that framework. Our ordinary matter, galaxies, stars, planets, is like the paint or decorative lights, only forming and concentrating along the strands and at the intersections of this invisible framework. The Big Bang created matter, but it is the dark matter framework that determined where that matter would concentrate, creating the large-scale cosmic structure we see today. We are living inside an architectural work built by an invisible architect. If dark matter is everywhere, even passing through our bodies right now, why can't we catch it? Because it hardly interacts with anything. It is a true ghost. To hunt this ghost, scientists have to build the most sophisticated traps in the world. This is the Lux Zeppelin Laboratory, located more than 1.5 kilometers underground in South Dakota. Why go so deep? To hide. Hide from cosmic rays and other particles from space that can create false signals. In this almost absolute silence, scientists hope that a rare dark matter particle will collide with a xenon nucleus, producing a tiny flash of light. It is an effort like listening to a whisper in a storm. Thousands of scientists around the world are holding their breath, waiting for a signal from the darkness. Besides waiting for a direct collision underground, there is another way to hunt for dark matter: listening for its echoes from the universe. Some theories suggest that when two dark matter particles meet, they can annihilate each other. This annihilation process creates an energy explosion, releasing high-energy particles such as gamma rays. We cannot see dark matter, but we can search for these characteristic gamma rays. Space telescopes like Fermi are continuously scanning the sky, especially the center of the Milky Way, where dark matter is believed to be most densely concentrated. They are looking for an excess energy signature, an echo from the invisible battle taking place in the universe, indirect evidence that the ghost is real. So, exactly what is dark matter made of? This is one of the biggest questions in physics. We don't know for sure, but there are a few leading candidates. The most famous candidate is called WIMP, which stands for Weakly Interacting Massive Particle. As the name suggests, they are thought to be heavy particles, moving relatively slowly and very rarely interacting with ordinary matter. Underground experiments like Lux Zeppelin are primarily designed to search for this type of particle. Another intriguing candidate is the axion. Unlike WIMPs, axions are extremely light particles. Instead of being individual bullets, they are thought to be like waves in an invisible energy field spread throughout the universe. Searching for axions requires completely different types of experiments, using extremely strong magnetic fields. The race is on to see which of these candidates, or something entirely different, will reveal itself first. We know that dark matter has gravitational force, but does it have any other interactions? For example, can dark matter particles interact with themselves beyond gravity? Some observations of colliding galaxy clusters suggest that dark matter simply passes through each other, like ghosts. However, some theorists pose a challenging question. Is there a certain dark force, a more complex version of dark matter, that allows it to interact with itself in subtle ways? Or even, could it interact with our world in extremely weak ways that we have not yet detected? The answers to these questions could open up a completely new dark sector of physics, with new particles and forces that we have never imagined. The gateway to other dimensions? And now, let us step into the realm of the boldest hypotheses. Some physicists speculate that dark matter may not be a type of particle in our universe. Instead, it could be a gateway, a connection to other realities. According to theories like string theory, there may be more spatial dimensions than the 3 spatial dimensions and 1 time dimension we know. There could be parallel universes existing right next to us, separated by an extremely small distance in another spatial dimension. Perhaps dark matter is the gravitational force of matter in that parallel universe, leaking into our universe. We cannot see that matter, but we can feel its weight. This is a highly speculative idea, but it suggests that deciphering dark matter might not just be about finding a new particle, but about discovering an entirely new structure of reality itself. The hunt for dark matter is one of the greatest and most humble journeys of science. It reminds us that the universe is much larger and more wondrous than what the naked eye can see. 85% of the cosmic book remains unwritten, and we are standing on the first page. The next generation of experiments, from massive underground machines to more powerful space telescopes, promises to bring us closer to the answer. Understanding dark matter will not only complete the picture of the universe, but may also completely reshape our understanding of the origin, evolution, and ultimate fate of everything. The greatest mystery of the universe is out there, waiting to be solved. Thank you for joining this journey into the darkness. What do you think dark matter is? Leave your hypothesis in the comments below. And if you love exploring the greatest mysteries of the universe, don't forget to hit the like, share, and subscribe buttons to continue this adventure together. Goodbye, and see you again.